Have you heard about something called a law of projection? What is law of projection? Alright. Let me ask you. In human body, which is the most faithful body part? Brain. Why? Because even if somebody is gone, right, it will remember it. Phantom limb. Right? Your limb is gone. It does not exist. But brain will get up in the night and say, oh, my hand is there. Oh, I am having pain. What is that? It means law of projection. What's law of projection? Law of projection says if you stimulate enough, you can't stimulate enough. Can you do that? No, you normally can't do that. Because normally you stimulate a receptor. Yes or no? Yes or no?
Yes.
So you stimulate a receptor, you don't stimulate enough. Are we done? Right. So when will you stimulate enough? When it's damaged. What is the damage now? It means the myelin sheath is gone. We are talking about anatomical damage, we are not talking about physiological damage. When the myelin sheath is gone, you have an exposed neural tissue. What's an exposed neural tissue? A tissue which does not have myelin. So if you have a damaged neural tissue, it means your myelin is gone, your neural tissue is exposed. And when you have an exposed neural tissue, you can stimulate it by just striking on it. Done? And when you strike or stimulate a neural tissue, then the brain will perceive that the stimulus has come from the receptor, even if the receptor does not have sensory supply or it does not exist in the human body. Means, if my median nerve's area of reception is tip of index finger, if tip of index finger is my area of median nerve, alright, this is an autonomous zone. Brain remembers this area as the receptor area for median nerve. If I stimulate my median nerve anywhere along my path, the brain will perceive that the sensation, the abnormal sensation is coming from the tip of index finger wherever the stimulus takes place is not concerned. Let's understand this. Supposedly, right? Supposedly we talk about the median nerve, right? That's how the median nerve goes. It starts from here, it travels here. That's how it goes. It got damage here. Now what damage it is? We are talking about an anatomical damage. Means there is exposed neural tissue. There are free nerve endings here. Now this area distal to it is not supplied. And this is the area of the receptor. Yes? Now when I strike on this area, going from the distal to the proximal, I will come to a point where exposed neural tissue is there. The moment I strike that, my brain center is stimulated and I will have an abnormal sensation where? At the tip of index finger. Why? Because this is the area for median nerve. Yes or no? I will label it as positive and I will put the date here, 28 September. I will ask the patient to leave and I will say that on striking this area, I feel tingling or abnormal sensation. It has to be abnormal because you're directly stimulating a nerve. It cannot be normal. Normal means stimulate a receptor. Abnormal is stimulating a nerve. I will label it as positive, means Tinel sign is positive. I will ask the patient to come at an interval, usually 3 weeks. I will repeat it. I will have two scenarios. Scenario number one, if it was neurotemesis, it's complete nerve transaction, it cannot recover. So it means it cannot recover. Means the free nerve endings will be here only. They will be lying here, they cannot go anywhere. So if I repeat it again, the moment I strike again, the same events are repeated. Stimulated, tingling. I will label it as Tinel sign positive again, but at the same point, so static. So in neurotemesis, I will label it as positive but static. The second scenario, maybe the nerve recovers. Maybe there was some recovery from proximal to distal. When the nerve recovers, it has to have two things. It goes from proximal to distal and there is a myelin sheath. And when the myelin sheath comes, then the free nerve ending is exposed. Now you have a free nerve ending at a distal point. Now you repeat it again. The moment you strike this point again, it will be positive. Now you label this as positive, right? And you put a date here. For example, you put a date as 20th October. And now you know the distance between the two and you know the time period. Distance upon time is equal to speed. And you can calculate the speed of regeneration, yes or no? Which is usually 1 millimeter per day. If you are recovering with this rate, that's called as a satisfactory recovery. We are orthopedicians, we are not worried about 1 millimeters. Broadly, we can also remember 1 inch per month. But 1 millimeter per day is a better answer. 1 inch is equal to 2.54 centimeter means 25.4 millimeters. In a month on an average we have 30 days. It means a loss of 4.6 millimeters, but we are not worried. Alright, so what is the area where you have Tindall sign positive? Both axonal masses and neuroid masses. But if you have to choose one, axonal masses is better because positive means progressive. Now there are two thoughts. Tindall sign, can it localize the area of nerve injury? Yes, but only in neuroid masses. It cannot do it in neuropraxia because it's negative there. Because it's negative because you need an electrical discontinuity for it to be positive. It is positive and progressive in axonal masses. So when the first time you did, you cannot be sure that this was exact site. It could have progressed by that time when you did it. That is why it cannot localize the area. It can only tell you about the nerve degeneration. So in your questions you are asked three things. Tindall sign negative, neuropraxia. Positive and progressive in axonal masses. And if PGI Chandigarh they ask you positive in, you will answer 2, axonal masses and neuroid masses. Are we good? If they ask you satisfactory rate of recovery, 1 millimeter per day. And what is Tindall sign for? Nerve regeneration. Are we good? Right. Please note this down.